Okay guys, what we're going to do here in this video is I'm just going to walk you through how this whole circuit works, and I'll walk you through the code. I'll explain to you how the H-bridge works. I did make another video where I made a lot of mistakes. I'm going to upload that too. I'm going to call that Watch Mr. Slow Debug. It's about an hour long, and I don't recommend necessarily watching me debug the whole process unless you really want to see how I go about and test all the components. Might be interesting for you to see how to do that, but it's a kind of a long video. This is a much shorter video. So let's talk about this cool, crazy component and what all these wires mean. All right, let's start up here. We have enable 1 and 2. This is going to receive a signal from pin 9. What that's going to do is it's going to receive a value between 0 and 255, okay? And it's going to receive that value from this potentiometer. So what's going to happen is, if the thing is on, it's going to read this value coming in from A0. It's going to divide it by 4, because when you do an analog read with the analog reads, it reads it between 0 and 1023. If I divide 1023 by 4, I get 255 approximately. Really close, right? So what I'll do is I divide it by 4, and then I'll send the signal out through either output 1, which is going to the motor right here. Let me just get rid of these so it's not confusing. Or output 2. If I send the signal to output 1 and I turn output 2 off, the motor will turn left. If I send the signal through output 2 and don't send the signal through output 1, the motor will turn right. So that's how I'm going to control the motor. These 4 pins are grounds. You don't need 4 ground pins, obviously. The reason why they have them is because this chip, this l293d, gets hot. So these 4 ground pins act as heat sinks. We ground both of them. This would work if I deleted one of these grounds. Check this out. See, it still works. This would also work if I grounded it over here. So there's some variation in how I could connect these. Just for argument's sake, just do this. That's how the book does it. But you don't have to do it this way. There's a lot of different configurations you could do for the grounds, okay? So again, we have output 1, output 2, and then we have input 1 and input 2. We are going to control which one we're going to shoot through and give it power based on the state of this button. So the way it's going to work, this is the pin 4. If we click it once, let me show you how it's going to work. So let's turn it on. Let's make it go slow. It's going to be hard to see. You can't really see it, but just know that it's going negative. And then when we click it, you see how it goes positive? Then when we click it, it goes negative. Click it. Again, it goes positive, negative. You get the idea. It's reversing the polarity. When you reverse the polarity of a motor, it either goes left or it goes right. So that's what this button's doing. Now, what's this other button doing? Well, if I click it once, it's on. If I click it again, it's off. This is the on-off button. And that's it, really. Let's do one more thing. If I click it on and I control this, you'll notice this number is getting faster because it's receiving more power. So it's 0, and as we go up, it's getting faster and faster and faster. A cool thing we could do is this. Check this out. Let's stop the simulation. And how's this work? Okay, no volts. Nothing's happening. Now, whoops. Oh, check this out. You see how it's 4.9 volts? Now it's 8. You know, we're not going to get 9. Let's go ahead and turn it off. You see how the thing just went up? Look how high that just went. It's hard to see, but it goes really high when you turn it off. Because it's getting, some of the power is getting shot back. Now, you don't have to use a diode like we did last time, because this thing has built-in protections for that. Just know that. That's why you don't have this thing hooked to Arduino, because you'll blow out your Arduino, all right? So that's it. That's the circuit. This pretty simple. Now you'll notice, hey, wait a minute. output 4, input 4, they're all blank. Why are they all blank? They're blank because we're not using a second motor. If you were using a second motor, you could go ahead and put these out to a second motor, right? We're not going to do that, but we might do that as an extension. So you could say, all right, output 4, input 4. So this input 4 would go to the another button. You could do the same button or another button or pin or whatever you want to do. Okay, so that's the way that works. Just know that this is one side here, this is one H bridge here, and there's another H bridge there to control another motor. We're only doing this motor. So again, this output makes it go one way, and this output changes the other way, makes it spin the other way. This enable pin receives a signal between 0 and 255, and it sends it over to either output 1 or output 2 based on whether it receives a signal from input 1 or input 2, what button we press. Let's look at all this crazy code. Here's all the code. So the way this works, let's start out up here. I made this in the previous video. Again, you can watch me make all this code if you feel so inclined. You just set up your button pin states. That's all this is doing. You set up your button pin modes. You write a low to the enable pin just so it's not on. You don't need to do this. I did this for debugging. All right, so now what I did was int on off button and int direction button. I said if on off button is equal to 0. What does that mean? Well, that means it was pressed. If it's 1, it's not pressed. Okay, so if it was pressed. If on off state, if the state is 0, make the state 1. Else, if the state is 1, make it 0. That will turn it on and off, right? Let's look at here. If direction button pin is equal to 0, that means that we pressed this button. So if it's 0, boop, we pressed it. Beep, we pressed it, right? If it's 0, what do? If the direction state is 0, make it 1, else make it 0. Okay, that'll make it go left and right. Now let's look at all this other stuff. The motor speed is analog right. You take the pot pin divided by 4. So remember, this is the pot pin. It receives a signal between 0 and 1023. And when you divide it by 4, if you divide 1023 by 4, you're going to get 255, which is the maximum value you're allowed to write to a PWM, to a pulse wave modulation pin, right? So now let's look at our wacky if statements, all right? If on-off state is equal to 1, that means we press the on-off button, and it was 0, now it's 1. So if the on-off state is 1 and the direction state 0, we're going to write input 1 to high. So we're going to turn it one way, and we're going to turn input. You can't turn them both on, obviously. One of them has to be on, the other one has to be off. Okay, that's all that's going on there. And you're saying analog right, enable pin motor speed. So you're saying, okay, shoot the motor speed over to this pin, and then it'll output it out to either, well, in this case, it'll output it out to output 1, right? Because input 1 is a high. When input 1 is high, it opens up this switch. When input 2 is high, it'll open up this switch. If input 2 is low, it actually closes the switch inside, so we can't do it. You could make one of these. Maybe in a video I'll make one. I don't know. We don't really need to. So if on-off state is equal to 1 and directional state equals to 1, this means, okay, the motor's on, right? We want it to go on, and we want it to go right. Now we'll go ahead and, okay, write input 1 pin a low, write out input 2 pin a high, and go ahead and write the motor speed. Else, if the on-off state is 0, so we turn it off, just go ahead and write a speed of 0 over to, don't send anything. Don't send any power, no power cycles at all, over to this enable pin, which will turn this whole chip off. That's what turns this chip off. It's a switch. It's another example of a, great, I can't delete that. Oof. All right. It's another example of a digital switch. I'm just going to refresh my page real quick because I did some things I shouldn't have. All right. It's a digital switch. So that's that. Is there any other code that you need to really examine here and sort of understand? No, that's it. Okay. That's it. Now, why do you delay? Well, the reason why we delay, a normal human could hit a button about 200 milliseconds, give or take, maybe 175. So you could throw that down to 175, but you can't put anything below 150 because it takes more than 150 milliseconds to press a button. Even if you have the most godlike reaction speeds and reflexes and ability to press a button, it'll still be around 150 milliseconds. So what will happen is one button press will register as multiple presses, and it won't have the right result on our circuit. Okay, so this was the video. I'm going to upload both. I'm going to call one, watch Mr. Slow debug, so you could watch me in this whole process. And I'm going to call one, well, this isn't called this. This is going to be called H-Bridge Motor Project. Okay? That's it. So I hope you guys enjoyed this. You found it informative. You get what this chip does. It's nothing too crazy. It's basic stuff. You know, you could mess around with the ground pins. You know, you get what the enable does and how it interacts with the input and output, 1 and 2. And you could stick another motor on the other side. Okay, so thanks for watching and see you soon.